4.2, day number 1, what is it that the derivative actually tells us? So let's call our green function here f. Let's call our blue function f prime. Let's analyze here, and with some goals of increasing and decreasing, as well as local extreme values. So how do you know if a function is increasing? Well, when a function is increasing, as highlighted here on f, it'll travel upward from left to right. All right, and that function is also decreasing from x on that interval. So we would say that f is increasing. F is increasing on the interval from negative infinity to negative 1.75 and looks like 1.75 to infinity. All right, and what that tells us is that the derivative is going to be positive on that same interval. All right, so you can see this nice connection here between f prime being greater than 0 when the function is increasing. Likewise, you can see that the derivative is less than 0 when the function is decreasing. So we'd say f, let's do this. Oops. Let's say then that f prime, f is decreasing on the interval negative 1.75 to 1.75, and the derivative is less than 0 on that interval. Okay, so when a function is decreasing, the derivative is less than 0. When a function is increasing, the derivative is greater than 0. And we're going to learn a little bit more along with that. Okay, so we said f prime was greater than 0 for an increasing interval on a function, and f prime is less than 0 for the decreasing values. But how about those local extreme values? Well, for those local extreme values, f prime will equal 0. And or f prime does not exist. Okay, so examples, f prime equal to 0. This would be a value where f prime is equal to 0, whatever x is there. And f prime not existing would be like a cusp, right, or an absolute value. F prime would not exist at these values. Okay, in this diagram here, I've highlighted a few things. We've got our function f, our derivative f prime, and I've highlighted these three locations, right, all at critical points, right, where the derivative equals 0. However, this max here is a max because our derivative goes from positive to 0 and then negative. Over here, the opposite, right, our derivative is negative, becomes 0, so that tells us either a max or a min as long as there's a change in sign of the derivative. So if the derivative goes from negative to positive, that means this will be a minimum value. All right, here is an example. This is not a min or a max, right? The function in red here does level off here and have a derivative equal to 0. However, it doesn't rebound and go the opposite direction. You can tell by the derivative. It's negative, becomes 0, and then becomes negative again. So that would not be a that would not be a max or a min. So on the description above, at a critical point C, if f prime changes from positive to negative, this will be a maximum. If f prime changes from negative to positive, this will be a minimum. And if f prime does not change sign at C, then f has no local extreme value. So the derivative might be 0, but it's not a max or a min. Okay, so here, in example number 1, find where the function is increasing and where the function is decreasing. the local extrema, and justify your answer. So the first thing we've got to do, and I'll do off camera, is find the derivative. Alright, here's the derivative. Now we're going to set the derivative equal to 0. Our next step would be to factor. And our critical points would be x equals -3 and x equals 4. So now what we'll do is we'll draw out a test interval. Okay, and we're going to sketch a graph of f prime here. We know that f prime equals 0 at -3 and at +4, so we're just going to test a few values. Let's go -4, we'll go 0, and we'll go 5. So what we'd do here is we'd test each of these. Plug them into the derivative. And what we're looking for is we want to know, let's see here, where is the function decreasing? Any local extrema, and justify our answer. I'll come back with an answer in a moment. Okay, so it looks like we've got an increasing function to the left of -3, a decreasing function between -3 and 4, and then an increasing derivative to the right of 4. So what this tells us is that f of x has a local max at x equals -3. Because f prime changes from positive to negative. Okay, f of x also has a local min at x equals +4 because f prime goes from negative to positive. And of course, we can answer this decreasing portion by just showing that f prime of x equals 0 at x equals -3 and 4, and f prime of x is less than 0 when x is between -3 and 4. Right? Tested and proven right there. Alright, so that's a great example of finding local extrema. Okay, find the local extreme values where the function is increasing and where the function is decreasing. Okay, so I'm going to go off camera and find f prime. Okay, here's our derivative. I'm going to set that derivative equal to 0 and solve. So 0 would equal e to the -0.5 x. However, I have a problem. F prime of x can never equal 0, ever. Therefore, let's see if f prime is negative or positive. I'm going to plug in just a nice number to work with. That would be -0.5 e to the -0.5 times 0. Therefore, f prime of 0, let's see, this right here would become 1, so I guess I get -0.5. So therefore, f prime of x is less than 0 for all x. And so it looks like there would be no extreme values. No extreme values. Check. Function is never increasing. Therefore, it is always decreasing. For this reason right here. F prime of x is always less than 0 for all x. Okay, let's look at this 2003 multiple choice question. The graph of f prime, the derivative of the function f, is shown above. Which of the following statements is true? Let's just highlight for a moment where the function f would be increasing. Looks like the function f would be increasing here because the derivative is positive. So that knocks this one out. It looks like it would knock c out as well. F has a local minimum at x equals 0. Problem with that, right? Here the derivative is negative, therefore the function will be decreasing. So if a function is increasing and then decreasing, this would be a local max right here where x equals 0. So that would be out. That one's out. F is not differentiable at x equals -1 and x equals 1. That one's got me thinking a little bit. But B, let's look at B for a second. F is increasing from -2 to 0. I like that because the derivative is positive on that interval. Okay, E is incorrect because a derivative does exist, right? There is an output value here at f prime of -1 and here at f prime of 1. Okay, if it said f prime is not differentiable, then we would consider that and say yes, because these are abrupt changes. There is no slope approaching from both sides to be equal. So E is out and our answer would be B. Okay, another multiple choice question from 2003. Must have been a good year. Let f be the function with the derivative given by the following. On which of the following intervals is f decreasing? Basically what you could do here is just test each of them, plug values in, or you could go ahead and analyze it. I'm going to go ahead and analyze it and just find where the derivative equals 0 off camera. Okay, so as I look at the function for the derivative, I know because of this x in the denominator that x cannot equal 0. That doesn't help me to get rid of any possible answers over here or to eliminate any, but I'll just continue to work from there. Okay, so then what I would do is probably move this 2 over x to the right side, and then I'd multiply both sides by x. So I get 2 equals x cubed. It's starting to show potentially either this answer or this answer as endpoints, but we'll see here in a moment. You never know. So we'd get the cube root of 2 equals x. Okay, so that's a critical point. So let's work this in C for a moment. Let's make ourselves a nice little plot here of f prime. I know that it can't equal 0, right? There's some kind of discontinuity there, but the derivative is equal to 0 at the cube root of 2. So then we would just test values. I'd probably test -1. Why did I do that? I'd do f prime of -1. Probably do f prime of, how about 1? And f prime of, let's go 2. So based on my calculations, I'm seeing a derivative greater than 0 here and here, and I'm seeing a derivative less than 0 here. So then I know that it looks like that would be our interval right there. All right. Have a great day. See you next time.